Hello everybody, in this video we're going to look at the teacher's manual example 3 from topic 3, lesson 6, algebra 2. And we're going to look at the fundamental theorem of algebra and then how to use that rational root theorem to find all the roots of an equation and then use that to find the complex roots of an equation. So this is a multi-stepped, very multi-stepped problem. And so the fundamental theorem of algebra, if p of x is a polynomial of degree n greater than 1, then p of x is equal to 0 has exactly n solutions in the set of complex numbers. If p of x has any factor of multiplicity m, count the solution associated with the factor m times. For example, the equation x minus 3 to the 4th power equals 0 has 4 solutions, and each is equal to 3. So again, a multiplicity of 4. It hits that 3 4 times. So example 3, what are the complex roots of the polynomial equation? Okay, we have a degree 4 here, so we have 4 solutions to this equation. We'll have 4 types of factors to this. So let's figure out what possible roots we have, what possible rational roots we have. So a naught is equal to -2, and then an, and I'm just going to keep everything the same color here. I don't know why I had red probably from before, is equal to 3. So let's think of all our factors. Well, -2 is plus or minus 1, and plus or minus 2. 3 is plus or minus 1, plus or minus 3. So these are our factors. Okay, so let's go through and look at how we can combine these. So it's going to be 1 divided by 1 plus or minus, and then 2 divided by 1 plus or minus. So these are possible roots or possible zeros, plus or minus 1/3, plus or minus 2/3. So the possible rational roots are 1/3, 2/3, 1, and 2. Now let's test. We're going to test with synthetic division. So we're going to test, 1, 3. And this is if you do not have access to a calculator. I know the last one I showed you with the calculator. This one is if we don't have access to a calculator. Remember, our remainder here needs to be 0. Make sure I have that. I don't have any placeholders. Right, so we're going to try 1. 3 comes down. 3 times 1 is 3. 4, 5, 6, 7, 7, 9, 9, positive 8, 8. And this one we don't have a remainder of 0. We have a remainder of 6. So what is not a possible solution? Or what is not a solution? Let's do a 2. And you're going to continue this on. If you have a calculator, again, I would just do the ask part that I did in the last example. But what we're going to find through synthetic division or through substitution, again, I would use substitution over the synthetic every time. We will find that 2 will be a solution. Oh, I lied. -1 and 2/3 will be a solution. 2 is not a solution. And there's a 44. I mean, this number is just getting bigger and bigger. So this already is not a solution. So what we'd find here is that 2/3 is one of our solutions. So I'm going to use 2/3. 3, 4, 2, negative 1, negative 2. And let's say we went through this whole thing. 3 comes down. It's going to be 2, 6, 4, 6, 4, 3, 2, 0. All right, so now we know that 2/3 is one of our solutions. Let's look at we're looking at the equation x minus 2/3, 3x cubed plus 6x squared plus 6x plus 3. And now I'm going to factor this one. And again, I told you before that using synthetic division reveals that 2/3 and -1 are the roots. So I'm going to use this one, and I'm going to divide the -1 into this polynomial, 3x cubed plus 6x squared plus 6x plus 3. So 3, 6, 6, 3. 3 drops down. 3 times 1 is -3. This is going to be 3. 3 times -1 is -3. 3 times -1 is -3. So that, again, is a 0. Right, so these are our two rational roots. These are our two real roots. X minus 2/3. Again, I'm changing the sign here. So this is a -1. I'm going to go with a +1. And then what we're left with, since we've tested all our roots, what we're left with is going to be a complex root. All right. And since I know this is a complex root, I'm going to pull out 3. I don't need 3 in that whole thing. We're going to reduce this. And because 3 is a factor, I'm going to pull it out to the front. It's the greatest common factor amongst this. And I'm just going to work with 1. And because we did test all our rational roots through the rational root theorem, we did try to do synthetic division to find all our factors. This is going to be the complex number. So this allows me to jump straight into the quadratic equation. Square root of 1 squared minus 4 times 1 times 1, all divided by 2 times 1. Remember A, B, and C. This is easy because they're all 1s. All right, so we get -1 plus or minus C square root. 1 squared is 1 minus 4, -3. Divide it by 2, which will be -1 plus or minus the square root of 3 divided by 2i. The book puts the I in the back, so this is -1/2 plus or minus the root of 3 squared I. All right, so we have 2 solutions here. We have 2 solutions here, which makes it 4, and we have a degree 4 here. So we have all our solutions, 2 complex, 2 real. All right, guys, and I hope this helps. I'll see you in the next video. If you have any questions, please feel free to ask, and I will see you in the next video.